Fermat solution 2001 number 23, Jimmy and Chris. A sequence, term 1, term 2, and term n is defined as follows. Term 1 equals 14, term k equals 24 minus 5t subscript k minus 1 for each k is greater than or equals to 2. For every positive integer n, Tn can be expressed as Tn equals p times q to the power of n plus r, where p, q, and r are constants. So we're trying to look for the value of p plus q and r. Basically, from the question, we have been given two sets of information. So we have to solve for p plus q plus r, and we know that t1 equals 14, tk equals 24 minus 5, t subscript k minus 1 for each k is greater than or equals to 2, and tn equals p times q to the power of n plus r. And we know that p, q, and r are constants, meaning that there's only one value for p, q, and r. A little further, since we have established that Tn equals p times q to the power of n plus r, and p, q, and r are constants, we can subtract one n from both sides and it will look something like this. A little harder. Now that we have established the two equations Tn and Tn minus 1, we plug those equations to the previous one, tk equals 24 minus 5, tk minus 1, which is the same as Tn equals 24 minus 5, Tn minus 1. Notice the two equations are the same except for the two variables, k and n. So the question is, how do we plug Tn and Tn minus 1 into the equation? Well, it's simple. Since we have already changed tk to Tn, we simply insert their equation into Tn equals 24 minus 5 t subscript n minus 1. So after plugging the numbers in, it will look something like this. Since we plugged in the equation, we have to expand it now. Once we finish expanding it, we isolate one of the three letters. In this case, we are isolating r. To make things easier, we can look at this equation differently. We will simplify the left side of the equation into p times q to the power of n minus 1 brackets q plus 5. Now, many of you will look at this equation and wonder, why does all this have anything to do in solving for the variables p, q, and r? Well, it has so much to do with solving for p, q, and r. As I have repetitively stated, constants do not change. They will always remain the same. Therefore, if you look at this equation again, you will see that exponent n is a variable. That means it will change, resulting in a change in the letter q as well. So this means if q to the power of n minus 1 changes, this will also result in the constant variable r on the right side of the equation to change as well. The only way to keep the right side of the equation constant is that we have to somehow turn the left side of the equation to equal to 0. Well, the only way we can do that is by turning q plus 5 to equal 0. Since anything multiplied by 0 will become 0, we can do the same with the equation below. From what I have accomplished, I can now manage to figure out two of the variables, q and r. Now we go way back to the beginning with our equation. Tn equals p times q to the power of n plus r. And we plug in each of the values of the variables into the equation. Then we isolate p until p is solved. Finally, by adding up all of the variables, negative 2 plus 4 minus 5, we get negative 3, our solution.